Neighborworks approached our organization and asked us to look at some alternative construction methodologies for producing affordable housing in the future. And so in collaboration with Neighborworks and the architecture firm Clockwork, we started to think through, back in about June of 2014, we started to think through what might that look like to integrate new construction technologies or new design elements into affordable housing.
I think what we set out to do was to investigate new and innovative ways of exploring building typologies.
We knew that we had to design something that was universal, something that could be flat packed, a home that could be possibly built in a warehouse in a controlled environment instead of out in the field where there's rain and weather delays.
Innovative systems that would expedite construction, such as helical pier foundations and other types of building that would cut costs, save time, and raise the quality of the house.
Most people have only seen stick-built homes, so that's all they know, and we're trying to push the envelope and do something a little bit different with this one.
When you're producing housing for working families, lower to moderate income families, it's really, really important that not just the house itself be affordable in terms of how much it costs to build, but it's also really important that it be affordable to operate and maintain over time. And so that's one of the things that really inform some of the design choices in this house. The concrete slab, the really highly insulated envelope.
Traditional stick frame home building consists of wood studs spaced horizontally 16 to 24 inches on center, clad on the exterior with plywood or OSB sheathing, and insulated with batt insulation. Structurally insulated panels, alternatively, are comprised of a core of 4 to 6.5 inches of rigid styrofoam insulation, clad on the interior and exterior with 7/16 inch OSB. And what this does is it creates a very strong, rigid panel product that can be shipped on site and erected in a matter of days.
Very high R value compared to stick frame construction and a higher level of control on the modular dimensions that you would use to design a house out of SIPs.
Again, this type of construction can be built from the ground up. It can be utilized in components for walls, roofs, and even flooring systems. And it creates a very tight thermal envelope.
In comparison to homes around here, the homeowner in this home may be paying maybe a quarter of the energy costs that their neighbors will be paying. And that just goes right back into making an affordable house.
This house, located at 423 Armstrong in the Strawberry Hill neighborhood, is a 2-bedroom, 2-bathroom, 1,100 square foot house.
We started this project about 3 weeks ago, and we have about another 3 weeks on the schedule to completion. And you can see behind me kind of where we are. It's totally dried and roughed in, and we're starting on interior MEPs, which is mechanical, electrical, and plumbing rough in.
There are lots of different housing markets, and so it's really important that we be able to produce a housing style that is adaptable to each of those kinds of markets, but also that helps to minimize some of the uncertainty about producing lots of different kinds of designs.
I think the design is very flexible. It can be manipulated for various neighborhood conditions. It can be clad in different materials that fit the neighborhood and the environmental conditions. It could be varied even on a given street so that one house has a different appearance than its next door neighbor, and it creates that type of varied scale and aesthetic condition that makes neighborhoods interesting. It has a vaulted ceiling in the living areas. It has a storage attic up above the bedroom spaces, which is also designed to accommodate future bedroom and bathroom for future needs of the homeowner.
It's got a single car attached garage so that people can get in and out of the elements safely. It also incorporates an underground storm shelter so that people can be safe in times of a tornado or other kinds of catastrophic weather event.
It is a requirement in some cities and jurisdictions, but one thing we did creatively here to save time was a pre-manufactured, pre-built storm shelter that was designed and built off-site, allowing us to do things on-site in preparation for it.
It should be a much healthier home. We're controlling the way the air enters the home and the way the air leaves the home in order to make sure that it's not what we call a sick house, where germs and bacteria, mold would enter and then stay there. So by looking at flat pack type construction or warehouse built construction, we feel that one location could build 6 or 7 of these homes every 4 weeks.
Even though it can be shaped and molded somewhat differently, it has the same build features, so it can be duplicated over and over.
We've learned a lot through looking at modular cabinets, for instance, just by going by an IKEA and finding affordable solutions for the millwork instead of waiting for millwork shops. The SIPS panels on a large order can ship within just a few weeks instead of the usual 8, 10, even 12 and 14 weeks.
The house design itself and the floor plan is hitting on trends in the marketplace currently. Open floor plan design, just easy living spaces that connect indoors and outdoors.
It was really important for us to work with the design firm to incorporate elements of design so that this house would be just as comfortable as a house maybe at a higher price point. In addition to being efficient and durable, affordable housing should be beautiful as well.